Welcome to our presentation and experiment about desert erosion. Desert erosion is a powerful natural process that transforms the Earth's surface. And in this video, we'll explore what desert erosion is, its causes, real-world impacts, and how to mitigate it. But first, let's dive into an experiment to simulate this process.
For our experiment, we will be simulating desert erosion using these materials: 500 grams of sand, 500 grams of loam soil, 500 grams of rocky soil, a handheld electric fan to simulate wind, and a shallow aluminum tray to hold soil samples.
As you can see in the experiment process, we evenly placed the sand, loam soil, and rocky soil in the shallow aluminum tray. The sand represents loose fine particles commonly found in deserts. The loam soil demonstrates a mixture of sand, silt, and clay with better water retention. And the rocky soil, composed of small pebbles, simulates more compact and erosion-resistant terrain.
During the wind simulation process, we use a GEO01 fan as our wind source, allowing us to apply different wind speeds, 1%, 50%, and 100% on sand, loam soil, and rocky soil for 5 seconds. We conducted the test at varying angles of elevation 40, 60, and 80 degrees using as observation at 40 degrees slope. At 1% wind speed, minimal movement was observed across all materials, with slight displacement of sand, stable loam soil, and minor shifting of rocky soil. At 50% wind speed, the rocky soil showed increased vulnerability, with small pebbles being displaced, while the sand experienced moderate erosion and the loam soil started to erode gradually. At 100% wind speed, the rocky soil experienced significant erosion, with pebbles rolling down the slope, while the sand formed small ripples and remained relatively stable, and the loam soil continued to erode but retained more structure. At 60 degrees slope, at 1% wind speed, the sand began to shift slightly downhill, while the loam soil remained stable and the rocky soil exhibited minor movement. At 50% wind speed, both sand and rocky soil showed noticeable displacement, with sand particles sliding down the slope and rocky soil pebbles being dislodged. The loam soil showed more erosion but retained its structure better than the others. At 100% wind speed, the rocky soil experienced accelerated erosion, with pebbles rapidly rolling down, while the sand formed small dunes and the loam soil began to lose its upper layer.
And finally, at the 80-degree slope, at 1% speed, the sand started sliding downhill, while the rocky soil showed minor shifting and the loam soil remained mostly intact. At 50% speed, significant erosion occurred in both the sand and rocky soil, with sand cascading down the slope and rocky soil pebbles moving rapidly. The loam soil started to erode and noticeably losing stability. And finally, at 100% speed, the rocky soil showed the highest level of erosion, with most pebbles displaced, while the sand continued to slide but maintained a stable layer at the bottom. The loam soil experienced the most erosion at this angle, with large portions being displaced.
Regarding with the explanation of the findings, our experiment shows that rocky and sandy soils are more vulnerable to wind erosion than loam soil, especially as the slope increases. At steeper angles like 60 degrees and 80 degrees, gravity accelerates the movement of loose particles, making erosion more severe. This process illustrates exogenic processes, which are driven by external forces like wind, water, and gravity. When erosion combined with the force of gravity on steeper slopes leads to mass wasting, where soil and rock move downhill due to the pull of gravity. This is similar to deflation, where wind removes loose particles.
Desert erosion impacts regions worldwide. The Sahara Desert, with its sandy and rocky soils, continues to expand, threatening communities and infrastructures in North Africa. In the Philippines, areas with rocky soils, such as parts of Ilocos Norte and Zambales, are prone to wind erosion. This leads to soil degradation that affects the local farming, especially in uphill and coastal areas. Meanwhile, regions with loam soil, like Central Luzon and Bukidnon, are generally fertile. But they can also experience wind erosion during dry season and/or deforestation, reducing agricultural productivity and increasing the risk of dust storms.
Wind erosion is a growing concern, causing soil degradation and reducing agricultural productivity. To prevent further damage and protect our land, we must take action. Mitigation strategies are essential to stabilize the soil and preserve ecosystems. Here are some of the solutions being implemented worldwide.
Initiatives like the Great Green Wall in Africa use tree planting to create windbreaks and protect the soil. In the Philippines, reforestation efforts in Mindanao and sustainable farming practices like contour plowing help reduce erosion and safeguard the land.
Through this experiment, we've seen how desert erosion occurs and its real-world consequences. By understanding these processes, we can take action to protect vulnerable regions and restore degraded lands. Together, we can make a difference in preserving the environment for future generations. That's all. Thank you for watching and goodbye.